12s, welcome back to it. It's Maths Masterclass with Leo. Today we are doing the second last part of number pattern. Number pattern is very much long and it carries almost 24 to 26 marks in maths. Okay, today we are doing the last part, which is solving for x. Say we are given the pattern that is x minus 1 is 2, maybe y, not y, 5 minus x, and then is 2, 3x minus 1. They're given this type of a pattern. They're saying this pattern is an arithmetic pattern. They're saying determine the value of x. They want to know the value of x for this pattern, while they told you this pattern is an arithmetic sequence. Right? If you remember very well, we said D, when we're dealing with arithmetic sequence, we're calculating common difference, where common difference is D is equals to T2 minus T1, and again D is equals to T3 minus T2, right? You know this. Then I can now equate this, which means it will give me T2 minus T1 is equals to T3 minus T2, right? Because, this is the same thing. It is the same common difference. It means I can equate the two equations, right? And then after that, I know what is T2. T2 is given as 5 minus x minus into T1 is given as x minus 1. And then T3 is given as 3x minus 1 minus into T2 is given as 5 minus x, right? And then I'm going to say 5 minus x plus 1. This bracket here, it's very important, guys. If you don't include that bracket, your answer is going to be wrong. This is equals to 3x minus 1 minus 5 plus x. And then 5 plus 1 is 6. This will be 6 minus 2x. This is equals to 3, which is 4x minus 6. And then rearrange, I'm going to have negative 2x, negative 4x is equals to negative 6, negative 6. This will be negative 6x is equals to negative 12. And then divide by negative 6, divide negative 6. Therefore, the value of x is equals to 2. The value of x in this case is equals to 2. And then always after getting the value of x, substitute it back here and see if it will give you a linear or an arithmetic pattern. So in this case, I'm going to have 2 minus 1 is to 5 minus 2 is to 3 into 2 minus 1. And then this will give me 1 is to 3 is to 5. Therefore, you can definitely see that your common difference will be 2. Therefore, this value of x is correct, because when I substitute this value of x back on my sequence, I'm getting that my sequence is an arithmetic sequence. Move to the next part. Now you need to calculate two variables, x and y. So you're given this sequence 1, x, y, 7. Right? You're given this sequence. They want you to calculate the value of x and y. Right? So in this sequence, you need two equations. This is a simultaneous equation, right? You need to solve two variables, so it means you must use simultaneous equation. So in a simultaneous equation, I know that T2 minus T1 is equals to T3 minus T2, right? This will represent my equation 1, right? And again, T3 minus T2 is equals to T2 minus, okay, I'm repeating the same thing. This is supposed to be T4 minus T3, T4 minus T3, then T3 minus T2. Now it's better. This will represent my equation 2, right? Now, let's deal with them in that manner. Let's start with equation 1. Equation 1, we will have, in this case, T2 is represented by x, minus T1 is 1. This is equals to T3 is represented by y, minus T2 is x, right? And then this will represent my equation 1. Then my equation 2 will be T3 minus T2 is, Why am I saying T3 again? It's fine. This is T4 minus T3. This is equals to T3 minus T2. Last term, T4 is 7. Not the last term, but T4 is 7. Minus T3 is Y. This is equals to Y minus X. Right? This is equals to Y minus X. And then this represents my equation 2. I can now make this equation and make it equation 3. Right? I can make it equation 3 and say this will be X plus X minus 1 is equals to Y. What did I do? Just took this X to the other side. Therefore, Y will be 2X minus 1. This is my third equation. I'm going to sub third equation in equation 2. Meaning I'm going to have 7 minus into 2X minus 1. This is equals to 2X minus 1 minus X. And then 7 minus 2X plus 1. This is equals to 2X. Okay, 2X minus X is going to be X. This is X minus 1. And then minus 2X minus X. Okay, this is equals to 7, which is negative 7, negative 1, negative 1. This is negative 3X is equals to negative 9. Divide by negative 3, divide by negative 3. Therefore, I can see that the value of X will be 3. Right? And then, from there, I can substitute, sub the value of X, sub value of X in equation 3. Then I'm going to say this will be Y is equals to 2 into 3 minus 1. This is 6 minus 1, which is 5. Then I can rewrite this in terms of a pattern, which will be 1 is to 3 is to 5 is to 7. Right? Then check if this will give me a common difference. 3 minus 1, 2. 5 minus 3, 2. 7 minus 5, 2. This is a common difference. Therefore, the value of X and Y are correct. Therefore, this is an arithmetic pattern. Right? Let's get the next question, which is now based on the quadratic. We're now dealing with the quadratic pattern. Next page. With a quadratic pattern, it's slightly different, but it's not difficult. It is just upgraded. Now, with quadratic pattern, you need to know that when we're dealing with a quadratic sequence or pattern, you have T3 minus T2. This is equals to, okay, being minus into T2 minus T1. This is equals to T4 minus T3 minus into T3 minus T2. Right? This represents your second common difference. This is your second common difference. This formula I showed you when we started with the number pattern, it represents your second common difference. This is where it works now. Okay, what do I know? What is it that I can calculate? I'm given a pattern, x minus 1 is to 5, minus x is to 3, x plus 1 is to 13. Right? That is what I have. There are two ways in doing this. You can either use this formula, or you can just directly go to this. Let me try to separate them, give them space so that I can show you a method that I preferred using. This is 5 minus x, and we have 3x plus 1, which is this is 13. Right? And then I'll say this one minus this one. It will give me 5 minus x minus into, but it's the same thing as this, into x minus 1. Right? Then this and that, it will give me 3x plus 1 minus into 5 minus x. and then here, this and that, I'm going to have 13 minus into 3x plus 1, right? And then, from there, I can now try to simplify. This will be 5 minus x, and then plus 1. This will be 3x plus 1 minus 5 plus x, and then this will be 13 minus 3x minus 1. This will be 6 minus 2x. Okay, let's see. Yes, and then this will be this and that. It is 4x minus 4, and then this will be negative 3x plus 12, right? This is my first common difference. This is the linear part. Now I come back and say this and that they minus, this and that they minus. What am I getting? I'm going to get 4x minus 4 minus into 6 minus 2x. Here I'm going to get minus 3x plus 12 minus into 4x minus 4. And then this will be 4x minus 4 minus 6 plus 2x. Here I'm going to have negative 3x plus 12 minus into 4x minus, okay, let's remove the bracket. Therefore, this will be plus. Simplifying, I'm going to get 2x minus 8. Is it 8 minus 10 actually? 4 plus 2 is 6. Why am I saying 2? 6x minus 10. Then this will be negative 7x. Negative 7x. And then plus 16. Then remember, this represents your D2, your second common difference. This also represents your second common difference. Then we can equate the two, meaning 6x minus 10 is equals to negative 7x plus 16. Rearrange, I'm going to have 6x plus 7x. This is equals to 10 plus 16. Then 13x is equals to 26. Then if I say 13x is equals to 26, divide by 13, divide by 13, x is equals to 2. X is equals to 2. I can substitute back here on my equation or on my sequence to see if this is really indeed a quadratic sequence. 2 minus 1, 5 minus 2, 3 into 2 plus 1 is to 13. And then this is 1, 3, 7, and 13. This minus that, it is giving me 2. This minus that, it is giving me 4. This minus that, it is giving me 6. This and that, 2. This and that, 2. Right? That is my solution. I can now clearly see that this is a quadratic pattern, meaning the value of x is correct. The value of x is equal to 2. Let's go to the part where we have to solve for x and y. X and y, let me clear some space here. Calculate the value of x and y. Quadratic. We will use the very same method. We're given what? We're given 1x, 1 is to x, is to 7, is to y, is to 21. Right? So they want us to calculate the value of x and y. They are saying this is a quadratic pattern. Right? This is a quadratic pattern, so you need to calculate the value of x and the value of y. So for me to calculate the value of x and the value of y in a quadratic pattern, I know, let me give it space again so that I can work well. 1 is to y is to, oh, this is x, is to 7 is to y is to 21, right? Then now, this minus that, I'm going to get x minus 1. This minus that, I'm going to get 7 minus x. And then this minus that, I'm going to get y minus 7. this and that, I'm gonna get 21 minus y. And then from there, this and that, I'm gonna get 7 minus x minus into x minus 1, and then y minus 7 minus into 7 minus x, and then lastly this one, I have 21 minus y. This is equals to 21 minus y is equals to not equals to minus. See, making mistakes. Minus into y minus 7. So about that. Then let's try to simplify them. We will have 7 minus x plus 1, y minus 7 minus x, which is actually plus x, and then 21 minus y plus 7. This gives us 8 minus 2x, y plus x minus 14, and then this one, it will be 21, which is 28 minus y, which is actually 2y, right? This is what we have. This is what we have now. And then let's see. From here, what do? We will say, remember D2. All of these things are D2, right? I'm going to say this equation equated to that. Then after that, this equation equated to that, right? Let's do that. So, meaning, here I'm going to have the first part. If I equate the two equations, I'm going to have 8 minus 2x. This is equals to this one, y plus x minus 14, right? And then, again, I'm going to have this one, y plus x minus 14 is equals to 28 minus 2y, right? And then, rearrange here, I'm going to have 8 minus 2x minus x plus 14. This is equals to y. And then this will be 6. Can you see? 8 minus 2 is 6. 6 plus 14 is 22. Is it 22? Wait, let's see. Oh, this is x. This is 22. This is minus 3x is equals to y. Equation 1. I'm making so many silly mistakes. Sorry for that. And then, lastly, I can now substitute this equation here. Right? I can now substitute this equation there and have 22 minus 3x plus x minus 14. This is equals to 28 minus 2 into 22 minus 3x. And then this is 22 minus 14. It is 8 minus 2x. This is equals to this one. It will be 28 minus 44 plus 6x, right? Plus 6x. And then rearrange, I'm going to have negative 2x, negative 6x is equals to 28 minus 44 minus 8. Then if I say 28 minus 8, I'm going to get, let me try to get some space here. If I say 28 minus 8, I'm going to get 20. And then 20, this is negative 8x is equals to 24, which is also negative. Divide by negative 8, divide by negative 8, then x will be 3. X is equals to 3, right? And then let's get y. Substitute y is equals to negative 3x plus 22. This will be negative 3 into 3 plus 22. Then this is a negative 9 plus 22, which is equals to 13. The value of x is 3, the value of y is 13. Let's prove it. Let's prove it. The value of x, we have now our equation or our sequences 1 is to 3 is to 7 is to 13 is to 21. And this and that, this and that, this and that, this and that. This is 2, this is 4, this is 6, this is 8, this is 2, 2, and 2. Therefore, our quadratic pattern is correct. That is how we can now get the value of x and y. Last but not least, geometric pattern. Last but not least, geometric pattern. Quadratic is long. It's not difficult, it's just long. You just have to be careful when it comes to making mistakes. You have to eliminate mistakes. Say now you are given x. This is a geometric, is to 8 minus x is to 18. They are saying this is your pattern. You have to calculate the value of x. Determine the value of x, right? So the first thing that you do, you know that r is t2 over t1, or r is equals to t3 over t2, right? So in this case, it means t2 over t1 is equal to t3 over t2, right? Then substitute. What is my term number 2? Is 8 minus x over x. This is equal to, what is term number 3? Is 18. Term number 2, 8 minus x. Then you cross multiply. This will be 8 minus x, 8 minus x. This is 18x, right? And then this is 64 minus 8x minus 8x plus x squared. This is equals to 18. And then 64 minus 16x plus x squared. And then x squared minus 16x minus 18x plus 64. This is equals to 0. Right? That is what we have. That is what we have. And then this is x squared minus 32x plus 64 is equals to 0. Can factorize this. And then x minus and x minus, because this is positive. Okay. If I say 32, if I say 32 times 2 is 64, and then 32 plus 2 is 34. This is equals to 0, and then x minus 32 is equals to 0, or x minus 2 is equals to 0, x is equals to 32, x is equals to 2, right? So, one other thing that you have to be careful of, x cannot be 0 in this case, because if x is 0, this is gonna give you math error. Again, x cannot be 8, because if x is equals to 8, this will give you math error. So these are the two criteria that you always need to check whenever you are calculating or whenever you are getting the value of x, right? So if you are getting two values, one value is equals to 8, therefore that value is out, because if x is 8, this is math error, right? That is how you can calculate the value of x. Now let's substitute both of them. We'll have 2 is to 8 minus 2 is to 18. This is 2 is to 6 is to 18. If I say r is equals to 6 over 2, this gives me 3. If I say r is equals to 18 over 6, this gives me 3. That is a geometric pattern, meaning this first one is correct. Let's check the second one. check the second one. Say 32 is 2. 8 minus 32 is 2, 18. Then this is 32 is 2. If I say 30, this is 26. 26 is 2, 18. Right? And then if I say the 26, let's see. Negative 32 minus 8, 2, 6, 24, which is actually negative 24. I'm struggling. I don't have my calculator, and this calculator is acting up on me. Then R is equal to negative 24 divided by 32. This gives me what? This gives me negative 3 over 4, because 8 can go into 24 and 8 can go into 32. And then again, if I say R is equal to 18 over negative 24, 6 can go into this and 6 can go into this. This will give me negative is 3 over 4. Yes, negative 3 over 4. Because 6 into 18, 3 times. 6 into 24, 4 times. Right? That means this is also a geometric pattern. Let's get the last question on this. Let's get the last question and see how do we